So I'll start with a bunch of apologies. So first of all, I thought I had 45 minutes. I only have 20, so I'll be talk fast. Second, it's a beta, and my display just disappeared. Great. Help. It's running Fedora, so we'll see. Okay, so it's a second slide. Okay, if I do it, it's probably a wrong button I pressed on this thing here. Okay, so it's beta because this is the first time you're my guinea pigs to give this talk. I do that every time at DEF CONF. Apologize for that. Be a bit kind when you do the review. Don't ding me too much. Introduction, Daniel Rieck, blah, blah, blah. Done Linux for a long time, work at Red Hat. You can read that later. We don't have time for it. Disclaimer. Nothing I say here can be construed any kind of commitment or forward-looking. Still, I work in the CTO office, so that's kind of self-explanatory, right? That is a strategy discussion we're having here. So what are we talking about? AI. I'll use AI as a term to cover the broadest sense of the buzzword, right? To cover basically everything from simple summary statistics and data up to cognitive systems. It's just a shorthand, right? You could be very specific, but that would be for deeper discussions in what the different kinds of AI are, right? It's a very diverse field where many things that happened over the last 30 years get put together. It's everything we're talking about has been in the making for 30 years. I think the key algorithm, which like in 2011, since 2011 we have made a lot of progress, and the key concept to make neural nets useful with backpropagation algorithms, that was an idea that was like brought up 30 years ago, right? But it took 30 years to get compute capabilities, the access, commoditization of compute, the cloud, internet, and the accessibility of data to a state where this became really useful. Right now, we're at a point where this becomes the most fundamental transformation of the industry since the Industrial Revolution, and maybe even more than that. Chris alluded to that in his talk. The transformation of human labor and the impact on society might be more fundamental than the Industrial Revolution, because in the Industrial Revolution, you could learn to operate a different kind of machine. We are not sure that's still the case at this point. That where we are going right now, if we keep going in that direction, this might fundamentally change the role humans have in this world. We are seeing this in pretty much every aspect of the industry. And the key change is, traditionally, we have built machines that do one specific task they're built to do. Even in computers, when we program, traditionally, even rule system, expert systems of the 80s, kind of the last generation of AI, what we called AI. And there's this quote from John McCarthy, one of the fathers of it. I said, once it works, no one calls it AI anymore. Right? But these rule-based systems, right, we still program for specific things. The difference now is that the new systems learn on their own how to solve the problem. And we don't necessarily understand anymore how they do that, right? They can give us a log, what they did, but it doesn't mean we understand why they came to a specific conclusion. And that's a fundamental change in how machines act. We're not talking about general intelligence at this point, right? But it is a fundamental difference to what we've seen in the past. And to quote Donald Knuth, this is according to a book I really recommend, Superintelligence. Donald Knuth said, it sounds like right now machines have succeeded at doing everything that requires thinking. It's just the things that people do without thinking that are hard for machines. He said it kind of as a sarcastic joke, but it's kind of true, right? Repeatable human tasks are being taken over by machines that learn on their own. And while it's not artificial general intelligence or human intelligence, it is super intelligent in specific tasks. So these machines beat humans at specific tasks they learned on their own. Right? Alphago Zero is a good example, right? It learned Go on its own and beat not only beat the other AI that beat the humans, and and it on its own beats the humans. And like we are at a point, and it's kind of cliche, but we're at a point where a machine can train itself to say, "I'm not a robot." Right? That in itself is kind of interesting. Right? So. My view is that every repeatable human task that's governed by any probabilistic correlation of input and output will be automated. Right? If there is some surveys with AI research, and where do you see, like, are we ever going to have generic, artificial generic intelligence, so human intelligence, artificial human intelligence, that kind of makes no sense what I just said, but artificial generic intelligence, and like not everyone believes that's going to happen. There are very strong positions that it's basically impossible, but there are a lot of people, and the majority of researchers think it's going to happen somewhere between 2040 and 2100. Right? So very fundamental change in everything we do. There is a strong consensus that in about 10 years, there will not be any more truck drivers, right? There will be self-driving trucks that take over, and the economic force behind that is obvious, right? They are optimized, they drive around the clock, they don't cheat, like, they have less accidents. It totally makes sense, right? The shipping industry will move to self-driving trucks. And for us, this is a trend that's expressed in the proliferation of intelligent applications. Right? Nowadays, every company using software is a software company, right? Every business is a software business because software defines business. And all of them apply AI more and more in their applications, whether that's just like the simple things like in finance and customer interactions and chatbots, but it goes deeper into the core business. And if you look at what we do as developers, as a software company, Red Hat, as the open source community, the things we do are even more susceptible to automation than most of the things that other companies do, right? Self-driving trucks have a big problem in trying to understand the physical world, right? That's the real challenge that autopilots have, is figuring out that this truck that's cutting you off is actually a truck, not a traffic sign, so you don't crash into it. That actually happened with a Tesla autopilot. In our world, it's all machine readable, or supposed to be. Right? We don't have the problem that we need to actually interact with the physical world in software programs. So everything we do is even more likely to be automated. The whole process of software development, curating, system administration, and I exited my presentation again with the wrong button, sorry. So the next step for us, for systems managers, systems administrators, for software development, is really to take this on and replace the concept of heuristic and fixed limits with learned models. Right? Everything here, that's a quote from Uli Draper, who is going to talk later on this conference. But it's true. Like for us, the next step is to apply this to what we do as a core business, right? Whether it's systems themselves, right? You can go into a Linux system, and there's a lot of stuff that's going on in a Linux system that right now, from scheduling to reacting to events, that right now is just statically programmed. And that could be much more efficient if you apply learning. Now you scale that to a cluster, right? Everything that's happening in a cluster, in a large scale-out cluster today, let's say, take an OpenShift cluster with Kubernetes, as the meta kernel, as we say. I know that's more the meta systemd, but that's a different discussion. If you take that, the complexity of what's happening is already too complex for human operators to understand. We're trying to correlate logs to make it traceable, what happens in a cluster. But now, a learned model can probably augment the human operator with the current state of the art, much better than just correlating the data. So this is what we see as the next step, applying it to systems, clusters, and to the software development and QE process. An interesting aspect here is that AI has a strong affinity to free and open source, right? Basically, you already have full access to the current state of the art of the software and algorithmic and research. It's also interesting that actually university and research are on par with the industry here, right? Which isn't, if you go into traditional software development, over the last couple of years, and Agile and DevOps and all that, the industry kind of moved ahead of research in many areas, so that what you do in the university is not necessarily fully applicable to the industry. In this space, it's actually back to research is ahead of the industry, and that is really interesting, like changing some of the dynamics you see in the market. The key point here is that data becomes what is the proprietary IP, and we have to start thinking as open source. As an open source community, we have to start thinking about what that means for us, right? So open source has one as a software concept, but we need to start thinking about open data as well. And that's really important because no amount of algorithmic sophistication can overcome a lack of data, right? Data is the key. The whole point, and the two key factors why we have this progress in AI today is two things, right? It's one, that compute capacity became available at that scale so you can actually do deep learning with deeper neural networks. But as the other hand, data became available. Right? We are aggregating data more than we've ever done. And that gives certain parties who aggregate most of the data a huge advantage. Right? So what does this mean for Red Hat? Right? The slide was the Red Hat vision for AI. The overall, this gives you an idea of how we think about it. You see it as a fundamental transformation. We think the next step is to apply it to the core of operating system software development. It basically segments itself from our point of view in 5 areas, right? The first one is data aggregation and access. We have some products in the space with Ceph as an object store. It's really good for if you want to store large amounts of data, but we want to take that beyond just having software. We are pushing to, for example, have a community-level data hub in CentOS and Fedora to aggregate data out of CentOS and Fedora processes, out of the software development process. We're doing that with our own systems and with systems in our cloud offerings to be able to aggregate data and then apply AI principles to the operation of the system and the software development process, integrate AI with CI, and move to basically a combination of test-driven development and AI to augment human developers and offload churn tasks. Of course, AI represents a workload, right? As I said, it's the biggest transformation in the industry. For most of our customers, AI is probably the most strategic area of investment, right? What drives IT budgets is what you're going to do with analytics and AI. And so we are working hard to enable AI use cases in core RHEL and Fedora and CentOS, then obviously, but for the product side in core RHEL. With GPU offloading, hardware enablement, the right core compute libraries, then make that available in OpenStack with vGPUs, so you can actually run this on OpenStack if you want to do virtualization or have OpenStack managed bare metal environments running OpenShift on top as a container platform. And we see OpenShift as kind of the center of gravity for this, where you get the full combination of an lifecycle management for software, which is really useful. When you do AI and data projects, data and software often go together, right? You want your environment to move with your project, and OpenShift gives you that integration. Kubernetes gives you the scale-out capabilities and enables you to focus on the AI workload, without having to deal with the underlying details. And we're doing a lot of work in enabling that end-to-end in upstream Kubernetes and in OpenShift as our product. So workload, and it's kind of obvious table stakes, right? We have to do that. The second part is what I mentioned just before, apply to our core business. So apply AI to software development, software maintenance, and systems administration. Move that into value we provide directly to our customers. We have some products or services today, like Red Hat Insights, which is predictive support based on AI, that basically tells you and solves problems for you in your platform before you know it. We have services in OpenShift.io, which is our software development as a service project, where we give developers guidance based on AI on stack combination and issues in their software stack during development, so you don't even have to run it and test it before you get the first feedback on the combination of packages, for example, you're using, the stack combination that might or might not be useful. And it tells you, oh yeah, there's a problem in your stack. We have seen this break for others, things like that. So we're going to move towards giving our customers an intelligent platform experience. Right? The software platform becomes intelligent. And then, finally, enable our customers to build their own intelligent applications by providing components directly from Red Hat or through our ecosystem and the open source community that you can use to then, based on open source, based on good data governance principles, access to data, write your own intelligent application in your own business. So that's the summary of where we are going with Red Hat. If you want to know more about where this is heading, there are a couple of talks here at the conference I recommend. Right after this is a deeper introduction into machine learning as one specific, the right now kind of key interesting space part of AI. I really like the second talk that's at 12:30. Will Benton is going to talk about data analysis and probabilistic structures, and he's one of the data scientists in the DICON team, which is doing Spark on OpenShift, so analytics and TensorFlow on OpenShift. And a really interesting talk I want to point out is a Cyborg Teams talk on Sunday, where Stavold is going to talk about how to basically have bots as junior developers in your team. That goes into how to apply these concepts to software development. There's much more, but that's the highlights. That's the talks I'll listen to, of course. And then, finally, I talked about superintelligence, right? Isn't that really dangerous? So, I think that the perspective of superintelligence is problematic, but I also think that it runs out of memory before it kills us. So I'm fairly confident we're going to be safe for some time, as long as the OM is there. Thanks a lot, and we have 5 minutes for questions and answers. So if there are any questions, we have a microphone somewhere.
Just repeat it.
Yeah, I will repeat it. So the question was, do I think that this will change how software developers do their job? So yes, I think it's fundamentally changing. So right now, it depends a little bit what kind of software developer you are, right? If you're, I don't think it replaces human understanding of customer use cases anytime soon, right? It doesn't replace your creativity anytime soon. But a lot of your churn tasks, the maintenance of software, the testing, the ongoing validation, that's going to get taken over by machines very quickly. So it's always you just use them to support you in running all combinations of tests automatically, offloading just the validation of tests you've written. You move a little bit to test-driven development. But then you'll see speculative patching and things like that, right? A lot of what we do is backporting, and there's no reason why you can't have a machine just try to understand how to apply fixes from into older versions and find out, like learn to identify whether that worked or not, right? So a lot of like the kind of figure out what's broken kind of thing, and try fixes, try solutions that have been tried before, are going to be pushed to machines, and then humans are going to do the troubleshooting, the deep solving of issues that go beyond the understanding of machines, or require any kind of like general intelligence. There's even in the if you think of testing and even like fuzzing and things like that will become stronger, right? So you can even have machines develop tests for you, right? But just trying adversary behavior and things like that.
Question. Which companies are doing the most interesting work right now in the AI space? Biggest competitors or organizations?
So the question is, which companies, organizations, or competitors are doing the most interesting work in AI? I can't answer that. Like it's huge, right? They're the obvious ones, like Microsoft, Google, Amazon, Facebook are leading the charge. IBM is pretty strong, although I don't see them as strong as the others because they don't have as much data from my point of view. Might be wrong, right? That's an external view. There are a whole bunch of very interesting startups in the space that are exploring all these pieces. Communities. Right now I see TensorFlow, Google and TensorFlow in the open source space as one of the key drivers and the integration in Kubeflow. So I think that's going to be similar to the Kubernetes success. I really like OpenAI consortium. They're doing really interesting things in reinforcement learning. But it's impossible to keep up right now. So I couldn't really hear you well, so I tried to paraphrase. So you're asking, is Red Hat thinking about doing actual services to customers that are AI-based? Is that the question? Yeah. So is it for Red Hat in-house products or customers? So the software we write is open source, right? So it goes into the community, and we do most of this development stuff in upstream projects as well as then taking it into our products. We're not fundamentally differentiating any of that. Right now, it's kind of, I would see two different pieces there. One is what we call AI-powered core business, and that's the applying AI to our own processes in open source and inside Red Hat. And all of that at the end will be made available to customers as part of our OpenShift platform because they are software vendors too. Red Hat is not different than the open source community or any other company using software. We also have service, but in that, like, the customer doesn't necessarily know what we do. It's the same software maintenance. They don't know it's AI based. We also have services that are specific inside. Thank you.
Please don't forget to leave your feedback on sketch.org website where you can find the schedule of this conference. Thank you very much.
Hey, how you doing? Oh, there are others here. And there are a bunch of adapters.
I had a question, but I ran out of time to ask it.
Yeah.
A lot of the things you talked about are related to, programs dealing with artificial intelligence. But a lot of the progress that is being made is with data, training, millions of pictures and so on. So what has the strategy with respect to getting access to data?
So let me hand this over quickly so he can get started.
Thanks. Will you stay on my presentation?
Yeah, I'm going to hang out.
So I tried it, it wasn't much.